Alright, today I'm going to talk about my final project in Engineering Technology 3375. I titled it Product Delivery Problem. The year's 2010. My name is Jake Cobb. I'm a junior in manufacturing engineering. So my outline, we're going to start off with the introduction. We're going to move to the background, then we're going to do our charts, our trend chart, our pie chart, our Pareto chart. Then we're going to go into our cause and effect analysis, and then we're going to go into our action plan. So for my introduction, we're going to review the data, we're going to identify the problem, we're going to find out why that problem occurred, and then we're going to propose a plan of action to remedy that problem. Okay, so for the background of the data, we have that our 2010 product delivery data had a sample size of 1,208. Our best month was March, which had an on-time percentage of 55.6%. And total units in that month, we had 99, and 55 were on time and 44 were late. And then our worst month was May with a percentage of 41.8% on time. And our total units were 122, and we had 51 on time and 71 were late. All right, here we have our chart. You can see that the chart was fairly constant, except for right here in May, which is our worst month. And then our best month is right here in March. And this is our May on time versus late deliveries pie chart. So this is the late deliveries in the red, and this is the on time deliveries in the white. We have 41.8% on time and 58.2% for late. That's not very good. And then moving on, we have our reasons for our late deliveries. We found that missing parts and broken tools were our most common problems that were causing our late deliveries. We also have engineering change, failed inspection, and capacity, and those only accounted for a little less than 50% of our problems. But the biggest two problems were these two right here, and they caused the same amount of late deliveries during May. And this is our first cause and effect analysis. I decided to do two because we had two problems that were equal. So I looking here at what causes broken tools. For our employees, sloppy work, so that would be like people not paying attention when they're putting the materials into the machine correctly, or just messing the machine up completely. Lack of sufficient training, that would be managers not training employees correctly. And for the machine, we have bad programming. The programmers could have made the machine program not correctly, and it could just be crashing the machine over and over again. As far as material goes, they could be getting the wrong material from our supplier. And then for our method, there could just be an overall bad tool path. And then on my second cause and effect analysis for what causes missing parts, I put on employees, just could be all around sloppy work, just employees not paying attention to what they're doing, not putting parts in the right places, or not putting parts on at all. I don't think a machine could really have a fault there. And as far as material goes, we could not have enough raw materials for our actual parts we're producing. And then as far as method goes, we could just not be checking quality where we should be. People could not be paying attention when they're supposed to be checking if the parts should be going out or what, or moving to the next stage in the production. So my proposed action plan is we should better train our employees. I kind of figured that most of our problems were employee problems. So I think that we should train employees better as far as machine operators go. They should receive stricter training, and then the quality assurance employees, they should definitely be more careful when they're overlooking the parts. And then as far as the next step, it would be better supervision over employees. So that would be better managers, better foremen, and just looking at parts after they leave the machines in each stage and making sure that each employee is doing what they're supposed to be doing. And that's it.